No niin, hyvää huomenta, hyvät kuulijat täällä yliopistolla ja siellä verkon takana. Lämpimästi tervetuloa kuuntelemaan Solange Locatellin esitystä metakognitiosta, erityisesti kemian opetuksessa, mutta varmasti sopii kaikkiin luonnontieteiden ja matematiikan opetukseen myös. Hän on väitöskirjan tekijä ja hän tulee tosiaan São Paulon yliopistosta. Eli siellä kasvatustieteen puolella tekee tätä kemian opetuksen tutkimusta. Oikeastaan ei muuta kuin olkaa aktiivisia ja kysykää häneltä tämän esityksen jälkeen. Ja warmly welcome. The floor is yours.
Thank you. Hi to everybody. Well, English is my second language, as is yours as well. So I will talk a little bit slowly, and if you have any questions, you can raise your hands, please. My name is Solange. I come from Brazil. University of São Paulo is the biggest one in my country, and I'm a chemistry teacher in the high school and at the university as well. Well, usually I used to do this lecture to teachers in Brazil, training teachers, and about 30 hours of course. And so I intend to summarize some aspects of the metacognition that I think it's very important for you. You are involved in chemistry education, yes?
Yes.
All of you, yes. You are going to be teachers, yes, in this wonderful subject, chemistry. It's okay. So I think we can take very tips here to improve the classes. Just a minute, please. Yes. Just to have an idea, I'm from here. 15 hours of flighting to here, Helsinki. It's very far. This is my city, São Paulo. I don't know if you have already heard about it. Ibirapuera Park, center of São Paulo. We have Paulista Avenue. It's a big place to know. There we have my from here, and this is my university there, University of São Paulo, just to have an idea. Well, I intend to talk to you about metacognition, some topics, because it's very hard to speak about metacognition in a few minutes, but some topics is possible. Possibilities of research. I don't know if somebody here wants to go to doctorate students.
Some of them.
Some of them, okay. So we have many possibilities of research. I bring here one example of metacognitive strategy that you can use with your students. One example, we have so many, but I bring here one example. And okay, the last part for questions. What do you have to ask? I'm going to start with a question. You are students. I'm a student here. Have you ever been studied for a test and had poor performance? Really? Please raise your hands. Yes. I will raise my hand either. Yes? It's interesting. In Brazil, in Finland, when I ask this question, everybody raised their hands. Because sometimes we really study for a text, really study hours and hours, and we don't get a good performance. And we don't know why. Oh, but I really studied and I didn't get it. What happened? So why I'm here. I'm talking to metacognition to help in some measure this. Do you know how do people learn? This is a problem. Normally, we don't know how to learn. We want to learn, of course. We are here, we are in the university, we want to learn. But actually, we don't know how to do it. No, I study, yes, but maybe in a wrong way, perhaps. What do you think is the most important factor in successful learning? What could you tell me? The intention and desire to learn, paying close attention to the material as you study, the time you spend while studying. What do you think about while studying? What do you think? If you have to choose one of these. Of course, all of them are important. Of course, all of them. 5 ones are important. But what's the most important in your opinion? Who thinks is A? Okay. Who thinks is B? The most important. C? Some of you. D? And E. Okay, A, C, and E is the most favorite of you. The intention and desire, okay, learning in a way, your own style, and what you think about while studying. This is for start our conversation. We have to know how the people learn, because if you don't, we can't get good results. Let's see. This is available in an interview of Dr. Shu. He's a psychologist of the United States. Wonderful. I love him personally. And he talks about how people learn. Students must not only learn the concepts. Of course, this is important, but not only. In addition, need to develop a framework of connections among the concepts. They need to know how ideas are linked together and what makes them similar or distinct. I'm talking here. You know many things. You are students a long time ago. You are students. You are a child. You are growing up. And so you know many things. And so what I'm speaking here will connect with your ideas about education, about how to learn, about everything you have seen in your life. And if it doesn't happen, you don't learn. Do you know about learning, meaningful learning? Meaningful learning. Ausubel, a psychologist, said about this theory. It's very complicated, but has an idea that's very simple and useful for us. Imagine, for example, you have a pet in your house, and you have to put this in a wardrobe. What do you need for this task?
I have a what in my house? Sorry, I missed the beginning.
Yes, you have a pant. Very many pants in your room, and you have to put in a wardrobe. What do you need for this? What do you think? What does she need to put the pants on the wardrobe? Does she get to put them just like this? Or she needs a hanger? Do you know what's a hanger? Of course. You have to put your pants in a hanger, and so you put on the wardrobe. Because if you don't, you can't put your pants there. Your pants will stay in a mess. It's not good for us. We don't like mess in our room. So the knowledge is like this. I'm talking to you just right now, and you are thinking about this. But if you don't get how to connect with your ideas, you don't learn. Doesn't make means for you. You have to connect what speaking here with what you already know. So you learn. This is the idea of this question. Of course, all of them are important, yes, sure. But the most important is what you think about while studying. If I'm speaking here and you are thinking about anything else, I don't know, boyfriend, girlfriend, it's not a good idea because you are not going to learn. You have to think about what I'm talking about and connecting the things, the ideas. And Dr. Schill highlights this point. He thinks that's very important, and that's why we study metacognition. What's metacognition? What do you think is? Some idea? They are all good students. Very. Yes? An idea about metacognition? Cognition is, for example, to think. To think is a cognitive process. What is metacognition? The first thing the people used to think about is this, like the frog, to think about your thinking. But it's not only this, but it's a way to start learning metacognition, to think about your thinking. Imagine in the morning you have a discussion with your mother, with your father, with your boyfriend, and in this moment you are thinking about this. Oh, I realized I didn't have to say that thing. Oh no, I was wrong, I was right. You are doing metacognition. You don't know that is the name in metacognition, but you are doing this. And we do this all the time. It's a high level of thinking. According to Flavel, a psychologist either, metacognition refers to one's knowledge concerning one's own cognitive process and products or anything related to them. And later in the same text, it's very complicated this text, but in the same text, he brings more towards regulation and monitoring. I will explain about all of them, but just to have an idea. Flavel coined this term in 1976. And so since this age, we have been used this term metacognition in science education, science and education in general. Metacognition, so let's start to understand. Involves knowledge about knowledge. What's this knowledge about knowledge? It's very interesting, knowledge about knowledge. Well, I know chemical equilibrium. Do you know chemical equilibrium? Yes? It's a very difficult subject. Do you really know chemical equilibrium? If I give you, oh, she's laughing. If I give you an evaluation just right now, you know chemical equilibrium? If you really know, I will give an evaluation to you, and it's okay, a text for you. You do the text, and it's okay. But sometimes you don't know if you know. It's very interesting, this. Knowledge about knowledge is concerning about, you have to discern about you know and you don't know. It's very interesting. For example, you can say to me, no, I don't know chemical equilibrium. I would tell her, good. Oh, how good? She's telling you she doesn't know and you say good. Yes, because she knows that she doesn't know chemical equilibrium, so she can study. For example, otherwise, she said, yes, I know, no problems. You can do a text for me. And I give you a text and you write very, very, very bad performance. So you really didn't realize that you didn't know. So this is the first step of the metacognition. You have to discern, or you know or you don't know. It's very interesting. The second aspect, regulation. If you know about metacognition, you can regulate your learning. You are learning something and you say, oh no, these things I have to learn more about because I don't know. I didn't master enough. Which can involve, this is very complicated, planning, monitoring, evaluation. So in this time, where you will have to work with your students, you have to allow them how to regulate these things. And it's very difficult. Maybe oh no, it's easy. No, it's not. It's very difficult to students to do this. I'm talking about 16, 17 years old, for example, when they learn chemistry. I think here's upper secondary. Upper secondary, yes. In Brazil we have some kind of high school, but it's the same. In this age, they can't do this alone. In some measure, yes, but if you help, it will be very nice for them, very helpful for them. They will learn better. I will show an example of this. Awareness. This is the topic of the psychologist that's very important. Awareness, I'm talking about skills. Do you know how to study something? You have text chemistry. Do you know how to study efficiently for this texting? Maybe yes, maybe no. Some people here perhaps is visual person. And if you don't know about this, you are going to just read lectures. And it's not good for you. It's not helpful for you. I'm a visual person. And I have to write down the things. I have to drawings. I have to make images about what I'm hearing. Some people know, some students just hear and it's enough. But we don't realize, we don't have the awareness of this sometimes. My students is like this. When I talk to them about this, they said to me, oh, I didn't know about this. Oh yes, really, I'm visual. Oh, I didn't know about this. And so the life of them move to a better way. Of course, they will learn better. I'm talking about a cognitive process. For example, thinking. So we have here three aspects of the metacognition that are all of them important as well. Could someone here learn from me? You could learn from me. It's okay for you? Yes?
Yes.
Yes, please. Yes, please.
Sorry.
Could you read it aloud for us?
That text there.
Yes, please.
Can you move that thing a little bit so I can see the words inside?
Yeah, that's the problem because there's a string and...
Oh,
okay,
yes, thank you. Yes, that's great.
Although all learners use regulatory process, to some degree, self-regulated learners are distinguished metacognitively by their awareness of strategic relations between regulatory process and learning outcomes and their use of specific strategies to achieve their academic goals.
This I have heard just right now in the conference last week. I heard about this. I thought it was very good because it's what we are talking about. So, when are you metacognitive person? When you can use your skills in a better way to have good results, academic goals, results, outcomes. This is the point. You have to help yourself using good strategies. Well, we have N strategies. You have to choose 1, 2, 3, 4 that works for you. That's the point. It's not easy. It seems easy to do this, but it's not. Sometimes I think I'm visual, but I'm not. because the people used to be visual, but everybody is visual. No, everybody is visual. No, some people are not visual. This is the whole. To sum up what I'm thinking, what I'm talking to you, I bring here a video, P8D Sandra Maguire. I don't know if talking about metacognition. She's chemistry educator as well, all of us here. If you know about more about her, I bring here the address, and I put the video for you. Yes. Okay. What I can. We have the sound. It's showing me, but it's not showing there. I have tested there.
Today we have Dr. Sandra Maguire. She's the Assistant Vice Chancellor for Learning, Teaching, and Retention at LSU, and we're talking about metacognition today. So first of all, what is metacognition?
Yes, great question. Metacognition is, the term actually was coined by a cognitive scientist back in 1979, Flavel, and it really refers to the ability to think about your own thinking. The way I like to explain it to students is, it's as if you have a big brain outside your brain looking at what your brain is doing, and it's analyzing the activities of your brain, asking questions like, is she just memorizing this information, or does she know it well enough that she could teach it to someone else?
So why is it necessarily important then?
Great question, because very often the way that we learn information is determined by the processes that we put in place. And so if you are analyzing how you are learning the information or how you're thinking about it, and it's not just thinking about your own thinking, it's being able to plan the strategies that you're going to use to learn certain pieces of information. For example, if you know that in order to master something, you've got to go through the act of pretending that you're teaching it to someone else, which is very different than just writing the information out or just reciting it and looking at a book. So it's really important because it allows us to move to higher mastery levels of learning than if we didn't actually analyze how we were using our thought process.
And how do you become aware then of how you learn?
Yes, I think first you have to recognize that your brain can analyze what it's doing. Very often we just kind of go through study strategies, study techniques blindly. But if you really recognize that, no, I need to step back and analyze exactly what am I doing. Am I using memorization techniques? Am I using recitation techniques? Am I using annotation techniques, writing about the information, and also looking at whether or not the strategy that I'm using is congruent with my learning style. If I'm a visual learner, that suggests that I should be using certain kinds of strategies. And it's the metacognition that allows us to really analyze what we're doing and how we're thinking about the task at hand.
Gotcha. And I know for me personally, I actually changed the way I was learning the subject. It was biochemistry. And I started just writing over and over again with the different pathways and everything. So, so it seems like, it's never too late to try this.
Absolutely. And what you did actually was a metacognitive act, because you recognized that I need to do something a little bit different. Maybe you weren't writing out the pathways initially. You were just trying to look at it and memorize it. And then you realized that, to be more effective, I've got to write it out. And so the metacognitive sophistication, I'll call it, really does increase as you go to higher levels in college and you are required to do those higher level learning tasks.
And these different strategies, can you give some specific examples? That one was writing over and over again, I guess, for me.
Okay, absolutely. Teaching the information to someone else. And that's why we highly recommend that students become involved in study groups where you're explaining the information to each other. I've actually had some graduate students say that they bought a whiteboard and use it in their room, and they pretended that they were the professor, and they would go through teaching the lecture. So there are a number of different kinds of strategies. Sometimes people will do a comic book illustration of a particular concept, or they might do a concept map where they're looking at the differences and the similarities of two concepts that might have given them difficulty in differentiating those two.
Okay. Yeah. Well, thank you for this, and thanks for coming in. For more information on metacognition or the strategies we've mentioned here, please visit our website.
What did you think about? It's very good. To teach to someone else, it's fantastic. I don't know if you use this strategy. Yes? Because when you have to teach to someone else, you have to know the subject. And in the time you are teaching to someone else, you realize what you don't know. Oh, this I don't know really, actually. How can I speak this? How can I tell this? Okay. Well, the part 2 is very brief, because I'm talking about just a little possibilities of research. What has been researched in metacognition regarding to science education? And what are the possibilities for research? If you want to engage in this task, it will be very helpful. References to research is an article of the 2 researchers there. They have analyzed 178 articles about metacognition, and the results are, they conclude 4 main things. There's a large number of research for the development of metacognitive skills, and less attention has been given to studies regarding to development of the metacognitive knowledge. So metacognitive skills, yes, strategies, yes, we have certain kinds of studies, but metacognitive knowledge, no, we have a lack of this. We have also a lack of studies to conclude the effectiveness of metacognitive instruction. We know that's good, we know that works, but we don't have studies about this. Yes, we have studies, but not a lot of studies. It's very interesting subject to research, too large. There is enough research on metacognition research with children from preschool and elementary school. Normally, we used to research on high school students and university students. The smaller ones, no. And that's very good for research as well, the other ones. few studies we found with respect to knowledge of teachers and professional development in relation to metacognition. That's too important because the teacher has to have the information about this because he's a teacher and she doesn't teach to his students about this. The students will not become metacognitive persons. And this is an article. I will give you the reference if you want to read in the end of the presentation. I will give you all the references. I think it's very good to continue in this study. Here I bring to you an example of metacognitive strategy. I have done this with my students in high school specifically. It's a electrochemical activity where I'm in this moment I'm teaching to them electrochemical. So I invite all of you to stay in pairs to do that activity with me. It would be possible? Yes, in pairs. It's very simple, it's not complicated because I just pick up a part of the activity, of course, and I would like to invite you, please, in pairs. Yes, just a paper is enough. A paper and a pen. Just to you feel how is the metacognitive strategies. Because if I just talk about it, it's not the same thing. It's good to feel how is it. Yes, come closer. Okay, with the teacher, it's okay. Yeah. Great.
It's okay here.
Always students.
Okay, super okay. Yes. All of you, 2, yes. Maybe 3, okay, no problems. Maybe 3, yes. Okay. What do I give the orientations for this test? Sorry. Students in pairs, like you are. I gave 2 classes of 15 minutes each. Of course, I will not give exactly the same. I just pick up a little part of the activity. We have 5 parts in this activity. Are you ready? Let's get started. Yes? 1. The students will predict. You make a prediction. I will explain right soon. You make a prediction. 2. Observation of a phenomenon, electrochemical phenomenon. 3. Explanation. 4. Metavisual observation. 5. Re-explain. Metavisual observation refers to metacognition. When I'm talking about thinking about images, figures, graphs, I call metavisualization. But it's metacognition as well, but it's more specifically. So I call here metavisual observation because you are going to work on drawings. Okay, let's start. I would like you to discuss with your colleague. What do you think it will happen when metallic iron and sulfuric acid solution are placed together? Don't worry about if you don't know. Just your opinion. Oh, I think it will explosion. I think it will change the color. What else? Okay. What do you think? 2 minutes, just 2 minutes. It's very quick, just to discuss with you. Please take note of the main ideas. Just main ideas. I think that it's okay. I will show another video.
Yeah.
Help me, please. Don't worry about it's right, it's wrong, it doesn't matter. It's your hypothesis. What do you think? Oh, I think it will explode. The students used to say, I think it will explode. It's okay. Okay, it's enough? More time? No? It's enough. It's just to have an idea, don't worry. For my students, I gave them 5 minutes because they had to discuss a little bit more. It's just to feel the activity for you. Now I will put here a video, and I want you to observe the interaction between metallic iron and sulfuric solution. I have made the video by myself. So pay attention, please. We have sound. This is the iron solution of SC. Madonna? Yes. Look at the difference. Okay, now you have observed what happened, what really happened. Yes. Yes. Okay. Yes. You observe, okay, I don't know if it is the same or you have predicted. Maybe not, maybe yes. Now is the most important part. Propose an explanation model by drawings, symbolic and submicro. What I mean symbolic? I want you to write down an equation, a chemical equation of the phenomenon. What do you think it is? No matter if it's wrong or right, it's okay. A chemical equation. And B, submicro level, it's more difficult for the students. Draw particles using balls. For example, one ball is hydrogen, one another ball is iron. What do you think about? Initial? How do you think it's initial? Before the interaction? And final, in the end of the reaction. What do you think the particles are? And a legend here, of course. One ball, black ball is hydrogen. What do you want? It's okay. You have 3 minutes just. To my students, I gave them 10 minutes. For you, you are teachers. 3 minutes. Almost teachers, 3 minutes. Again, don't worry about it's wrong, it's right. It doesn't matter. It's your hypothesis. Take pictures of them. Distance. This is
Tuo on siis se suolantoisuus. Sen sulfaa. Kun jos olisi autoksi, niin se olisi nuosten väristä.
I want to teach here. Masha, I want to teach here. They are good students, so I want to teach here.
Mikä tässä on vähän? 2 minuuttia.
I love to do lectures.
Yeah.
I love
It's looking good.
I like to
Ah, yeah. You should have. Yeah.
Ai niin. Niin taas yhden jo, eli 2. Niin on tähän verkkopussa. Luskaksuuna. Pitää vähän. Pitää muuta sitä. Jos laitetaan tämä 3, niin sitten tuo on 6. Jos laitetaan tähän 2.
And the drawings, I'm seeing. You have done this, all of you, I think. Now this, the drawing, let's see. It's very difficult to do this. Representing by balls, hydrogen balls, iron balls, iron balls. The gas. It's your opinion, it's your hypothesis, don't worry about this. It's wrong, it's right, it's okay. I tell this to my students, it's not problem if you're right. I wish my students privilege.
Täällä jossakin tulisi taulu, missä
More 2 minutes? I think it's enough, yes? 2 minutes? Okay?
jos täältä löytyisi
Yes, my students do the same. Yes,
just
they
check
do
that.
this, yes. Many particles. The initial is here.
This is the iron layer of how it's and here is the sulfuric acid.
Okay.
So this oxidation is the word. Yes, reduction. So
Redox, yes.
so the iron give the sulfuric acids. So this with the hydrogen is the bubbles we saw in the video, and the top layer of this is now the iron sulfate.
Okay, sulfate, yes. So you have an hypothesis.
Yes.
Hypothesis. They finish.
Sarjista, kun niitä oltiin tuolla. Täällä jossakin on siellä. Se ei menee.
I will not tell you people are you.
Nopeasti kerrottuna menee.
Niin on. Siis tää on aika helppoa silleen. Rauta nolla
Se on asiantuntija tavallaan kaikkein semmoinen. Niin on nyt joku meistä.
I think it's okay. Yes. Many drawings. I'm proud of you. Thank you. Beautiful. Really. Well, this is the part 3, sorry. Remember we have 5 parts. Now, I want you compare your hypothesis with the drawing below. Don't scare, please. Okay? Because my students used to scare about it. Oh, it's okay. Just to compare, I'm bringing to a scientific hypothesis. It's not a correct one. It's a possibility of answer. Maybe you did different, don't care about this. And now, this is the metacognitive step. I'm thinking about what I have done. Identify differences and similarities. Attempt to rebuild or ratify ideas. Certainly, it's different, but not necessarily is wrong. That's the way. What is the difference? Oh, yes, this is the difference, but I think it's okay. It's right what I have done. It's no problems. I would like you to write down the main ideas you discuss with your partner. What the difference? Put for me. The difference are similarities. So I think my drawing is correct. I think my drawing is partially correct. Okay, what do you think? It's very difficult. You have to understand the drawing and to think about your own thinking. It's very difficult. 2 minutes? Yes. Unfortunately, I would like to have more time so we could discuss. It's just to have an idea of the activity. Don't worry about this. We have here, I forgot to explain, the iron, metallic ion here. Here we have hydrogen ions. Sulfate, I don't have to put here because it doesn't reaction actually. So if I put it's okay, but I don't have to put here, the sulfate here in the illustration. So I have here iron representing here, submicro representation. Hydrogen ions that are here, free in water. I tell to my students, they are swimming here in the water. Here we have the ions that didn't react. We have some ions oxidated state here. This ion lost actually 2 electrons, so they are here ions, ions, and here we have the bubbles, the gas, hydrogen gas. It's just to help you how to think about what you have done. 2 minutes, okay? Let's try to identify differences and similarities. It's my research major. Doctoral research. I videotape the students doing their activity. Translating, transcription, all the things. Now I'm analyzing. How is the feeling about this? Is difficult or is easy to do this? It's that why I propose you to do it, to feel how is it. My students had this 100 minutes to do the activity. It's a long activity. Here, just some chunks of the activity. What do you feel? Do you think it's easy? Difficult?
Easy.
Yes, you can say. Okay.
I think it's semi-what easy what we have just done, but compared to actual students, I don't know how hard is that then.
Yes, I saw your production, and it's very similar, but you just represent the few particles. Of course, you didn't represent this kind of this quantity of particles, but it's the idea. It's okay. Yes, someone else. And it's good you could recognize this. Some students can't. They saw their production, they look at their, oh, it's wrong. It's totally wrong. And your production, for example, is totally different from this. But it's right. It's another way to represent. Yes?
Yes, we have some differences there. For example, in that picture there is no sulfate ions there.
Yes.
And we think it's important to have sulfate ions, at least the last picture where it makes a bond with the iron ions. And we think there comes the black color for the...
Yes, because you thought it was going to stay together, iron and sulfate.
Yes.
Precipitate, solid. But it doesn't. It's soluble, yes? In water. He dissolves in water, so they don't get together. Why did we have the black color? It's interesting. The black color is due to the iron that is oxidizing. So you get that color, the black color, in the surface of the iron. What else could we say? And what about you? Yes. Your drawing, it's the same, it's different.
It's quite different because actually we have only those ions or molecules that are bound together.
Yes.
Yeah, not the free soluble ions.
You know, a misconception that's very frequently with the students is to represent just one particle, because they think just one particle reacts to one particle, and we have moles of particles reacting. Moles, too many atoms and molecules and particles. In your case, it's different because I didn't have time for you, just 2-3 minutes. How could you do many atoms and molecules and particles? It's not possible. But if I had you one time, oh, you have 1 hour to do the drawing. Yes, probably you would research like these guys here. They were researching, and so you improve your drawings. That's very normal. But the students, even though you give them the time or they want, they don't do it because they think one particle reacts to one particle. And this is an important misconception about reactions. You know, when you will teach to your students, you will realize this. They represent just one. I don't know if you realize that the size is different. Yes, really, because it's difficult to realize this in such time. This hydrogen is very small compared to hydrogen molecules. The atom here is bigger than the ion. And with the drawing you can see this. And you can recognize or not. And the researchers in this topic highlights this either, like a misconception. They don't know, they think the atoms have the same size. Iron has a size. Iron has another size because he will lose the last layer here. Remember, he lost 2 electrons, so he's smaller now. And this ion is different from the atom when it's neutral. Do you remember your classes of chemistry? Yes. And so, with this strategy, you can discuss all of these things and much more with your students. In the next class I gave to the students, every one of them, third one, 15 groups, they come here and show their production, and they explain what's similar and difference, like you did here. Very short time here, but like you did. And so we can construct with them. Because if I just say, oh, this is right, okay? I don't care about what you have done. This is right and you have to know this. The students don't learn like this in this way. They have to rebuild their ideas. Oh, but I didn't think about this. Oh yes, this part it's okay for me. This part I don't get it yet, and it is normal. We are learning, so it's very important to have this time to discussion with the students and to rebuild. And there is a metacognitive step again. In the next class, they will have to think about their things again and to reconstruct their ideas. So they make connections, and that's okay. They can understand.
Yeah. And also it is a model that we will show it as you want them to realize. Also, like they are floating in the air. There is no water molecules around.
Yes.
So if you want to make it perfect, maybe use some simulation. But then there is so big those atoms. It looks like
simulations are better because you have 3D dimensions. It's better to understand because here we have a vision of 2 dimensions.
Yeah.
And without water.
Yeah.
And I told this to the students, I will not put water here, but you can put it, it's okay.
Yeah.
Like
I wouldn't put the water because then it's because it's I have to discuss, it's like a nature of science. I have to discuss why there is no, I have to talk over and then come with this.
And so it could be another step because you can dip the knowledge here. If you have water,
my drawing skills are not so good, it looks like a mess.
Yes.
That's why I don't put it.
Yes, this is the way, the reason I didn't put water here. It's so really a mess. But it's important to dip after these classes. You can put here water, and the oxygen is directing here because it's negative. So we have attraction here, and so this is another discussion, but it's very important as well. And really, I gave here one focus, but we have any focus you want. It's very complicated electrochemical, you know. Interesting this suggestion you are talking about, because some students put water here, and it's not wrong, it's right.
Yeah. But also a level, this is like upper secondary level. If you call lower secondary, they don't have anything about knowing what stuff.
Oh yeah, yes, they know. Oh no, they know. But I think it was going to be very difficult to deal with some aspects, because this is difficult.
Yeah, in Finland, polarity comes in upper secondary level.
Oh yes, yes. We teach about polarity. Yes, and they asked to me about the water, and so it's wonderful. We can discuss, and I'm drawing here. Oh, water. Yes, let's put water. How it would be with water, and sulfate. Why don't we put sulfate? Let's put sulfate. Okay. So it comes increasingly difficult when you are putting another features in the figure, but it's okay. That's very interesting, because I have 3 classes there, and I had 3 discussions in each of them, different discussions. In one of the class, I took 3 classes to discuss. In one of the class, just 1 class, it was enough. Depends on the interest of the students, and I like it. Okay, water, let's put water. Sulfate, let's put sulfate, and we are discussing. And that's the way. The classes are not the same, and I'm talking about the same students, about the same school. They are very similar, but the interests are different. And I think it's very good. Okay, great. Let's see. Well, I would like to discuss a little bit more, but we don't have time. But I think you get the idea of the strategy, yes? The idea of the strategies. Students' hypothesis, my students, for instance, to have an idea. 2 students, a girl and a girl, 2 girls here. They proposed this model. The equation here, it's not correct, has this number 2 here, but it's almost correctly, and it's very interesting to discuss with them what's wrong here and what's right here. Another example. They are high school students.